All right. Good morning, good afternoon, or good evening, depending on where you're dialing from. And thanks for joining us this morning for the Docker webinar, the most common questions IT admins ask about Docker. Just a quick couple of housekeeping notes before I get started. As always, we are recording this session, and it will be posted and sent to you, so you'll have access to the recording after the webinar. And also, I will be taking questions in the Q&A panel on WebEx. So I will address all the questions at the end of the webinar, and so if you can please use the Q&A and not the chat function, that just helps to make sure I can get through all of the different Q&A. So let me get started. So my name is Jenny Fong. I'm the Director of Product Marketing at Docker, and what we have today is learnings from a lot of the different events and trade shows that we've been to in terms of what are the common questions we hear from IT admins. Let me get this in the presentation mode. And so a lot of this is part of our IT Starts with Docker learning series. And so some of you may be joining us from that. There's a website called www.docker.com/itpro. That's where you can sign up for updates. We started this about 2 weeks ago with the Docker 101 webinar, and today is a follow-up to that. Next week on Tuesday, we have the business value of Docker. And so this is, now that you have some of the basics, let's figure out what are some of the reasons to look at Docker for IT use cases. And so please go and register and sign up and join us for that one on Tuesday, same time, 10 a.m. Pacific. So let's go through some of the top questions that we typically hear from IT admins or sysadmins when it comes to Docker. So first is, isn't Docker just an open source tool for developers? We're very proud of our open source heritage and how we were able to grow Docker very quickly. But really, Docker has three, if you want to call it, parts of the family tree. So we have the open source framework, which is now called the Moby project, and that is something that allows our open source contributors as well as our ecosystem partners to build and create a container platform using the parts of Docker that were created originally by our founder. So this open source project is very popular amongst our ecosystem. And continues to be a thriving project on GitHub. And if you are representing an ecosystem partner who wants to make your products integrated with the Docker platform, that's where you would go, is to the Moby project. Now, out of the Moby project are two different products. There's the Docker Community Edition and Docker Enterprise Edition. So Docker Community Edition is, again, based on the Moby project. It's a free community-supported product, and the intended use is for developers and small teams who are more do-it-yourselfers and or are just getting started with Docker. Now, Docker Enterprise Edition is a subscription-based product, and this is where we start looking at more of the enterprise use case and production deployments. So when you talk about running containers in production, you are really looking into a Docker Enterprise Edition type solution, which includes lifecycle management, monitoring capabilities, etc. So this is the Docker family tree. Let me kind of go back in history and kind of explain how we got here. So in the beginning, it was a Linux-oriented open source tool for developers, and that is what we are known for today with the millions of users of Docker Engine and the strong community behind that. But now we really do see that there are many purposes and there's many different audiences that we're addressing with our Docker platform. So we still have that strong developer community who want to experiment with and play with the leading edge of our technology. So the way that our Community Edition works is there is a monthly release for the Community Edition, which is considered our Edge release, and then once a quarter or once every 3 months, something called a stable release. We still have our operations community who are being asked to manage and operate and secure those containers that developers have used or have created, and so we are addressing that particular audience. And then, of course, the enterprise audience, which is running business-critical applications in containers at scale. And then, of course, we are looking to make sure that our solution fits in well with all of our partner ecosystem solutions. So this really becomes the one platform, is the Docker platform, which is available in 2 different editions, Docker Community Edition and Docker Enterprise Edition. All right, so following that, we often hear from customers when they're first learning about Docker, they are curious, is Docker a type of hypervisor? And this is a recap of some things from Docker 101, but the answer is yes and no. So yes, in the sense that it is an abstraction layer, but no because or abstraction technology, but no in the sense that Docker is installed in a host operating system. It's not installed on bare metal. It is instead a process within the operating system which allows the different containers to share the OS kernel resources. So basically, if you, even though this is drawn as something on top of the host operating system, you can also think of it as a process within the operating system. What happens is different containers will want to get access to the underlying resources, and Docker isolates and segregates those requests at the operating system layer. So it is really much more of an application level abstraction. If you think about virtualization and hypervisors, hypervisors are really an infrastructure abstraction. So with that, one of the things that you can see in the right is that on top of a hypervisor, when you run a virtual machine, virtual machines will always have to have a guest operating system. And in a container, the operating system, again, is underneath the container. So the container itself, it runs on an operating system. It's not inclusive of the operating system. So those are kind of the key differences between what a hypervisor is and what Docker is. But these can be mixed and matched, meaning you can run containers inside a virtual machine. Again, because Docker is installed in an operating system, it can be installed in a guest OS, which is inside a virtual machine. Docker can also be run bare metal, and that would be running directly on top of the hardware installed on top of the host operating system. And so you can mix and match depending on your needs. Which leads to, should I run containers in virtual machines or bare metal? We get this question quite a bit, and it's often difficult to respond because it really depends. There are some key differences in terms of operating in bare metal and operating on virtual machines, but the reasons to choose one over the other are going to be very customer dependent or use case dependent. What I've done here is just to highlight some of the reasons you may want to run on bare metal and some of the reasons you may want to run in virtual machines. So let's look at why you may want to run on bare metal. We will talk about a little bit about resource efficiency in a minute, but suffice to say, because you're sharing a single host operating system running on bare metal, instead of having multiple copies of an operating system, there is more efficient resource utilization or less overhead when running on bare metal. So if you have one physical host with a single operating system running, dozens up to hundreds of containers, you will have less overall overhead. The next is possibly better performance, and this is, again, if you consider that virtualization gives you really close to true bare metal performance, but not quite. So if you say like it's about around 97 to 99% of what you can achieve on bare metal, then you can say also the same thing applies to containers running on bare metal. So there could be a performance edge depending on the application and how it's designed. What we often see for customers who choose to run bare metal, and the reason they do so, is that they're looking at Docker for a greenfield project. And so tends to be that the customer is looking at an infrastructure purchase anyways to support this greenfield project. And in doing so, they can decide what the memory and CPU distribution on those physical servers are, and really kind of prepare the environment specifically for running Docker containers. And so hence there is, you know, an opportunity to choose the hardware to run it bare metal in a greenfield environment. So now let's talk about the reasons to run in virtual machines. So one of the key reasons that we see customers choosing to run inside the virtual machines is it's already what the majority of their data center is. It's based on highly virtualized environments. What that means is that there are different tools, things like logging, things like backup, and other things that are integrated well into the IT processes already based on the virtual environment. So by layering in Docker in a virtual machine, you're still able to leverage all of those existing tools and processes. Now, another reason is there are customers who are wanting to run containers side by side with regular virtual machines or non-containerized virtual machines. In this case, you can run them side by side, similar to the drawing that we saw a few minutes ago. One of the things that virtual machines does provide is granular resource controls in terms of things like isolating and dividing resources to different virtual machines. And so some folks would want to leverage virtual machines for that particular capability. And related to the first point, you know, there's a strong and mature ecosystem around virtualization. And so, again, being able to leverage those existing tools that already exist in the data center without having to look for new ones. So in the end, it really does depend on the needs. It depends on the use case. It depends on your budget. It depends on what you're trying to accomplish. And so there are advantages to both, and it really will end up being a decision you make. Docker is pretty agnostic to this. We, you know, want to support all infrastructure platforms, and that is something that, you know, we leave to you to make the right decision. So I touched upon this, which is the question, how are containers more efficient? There's a couple of key reasons behind the efficiency and the less overhead, and so I want to try to explain this, and this also touches on some of the content we covered in the Docker 101 webinar. So the base of this is how we build a container. A container is actually based on an image that has base layers that are read-only. So basically, when you build an image, you're taking the underlying kernel, which can be a Linux kernel or the Windows kernel, and you're adding these read-only blocks that are based on the pieces that are, or the tool sets that you need for an application. Everything in blue on the right here is read-only until we get to the top layer, which is a readable, read and write. We use a system called copy on write, which means that, let's say this is our application as it shows here. If we access that application, change some data or change something, that is stored in only the top piece, and the bottom remains the same because these are read-only blocks. So let's take another look at this in a slightly different view. So imagine that we're running some PHP-based code on some Linux operating system. Again, these base images are read-only. They are fixed in place, and now we can run several different containers that have the same stack, the same operating system and PHP, and each of these containers on top are custom to the specific application that we're running, and that is the read-write layer, and it changes only whenever you change a container, it only changes this layer without changing the other bottom layers. What this really means, though, if you think about it, is this. So when you can share layers, these layers don't have to be repeated, and that is a big difference from a virtual machine. So if you think about a virtual machine, if you had 6 different apps, as we're talking about in the blue box, we would have 6 different stacks, each with you know, the full stack. So it would be Ubuntu, Java, Apache, and Maven for the first one, Ubuntu, Java, Apache, and Maven for the second one, and so on and so forth. So you would have full copies. In a virtual machine world, you would have full copies of all of these different stacks for each application because they would be completely segmented and isolated on its own. But in containers, what we are doing is creating these base layers that are shared. And if they're shared, the 2 containers here don't need to actually replicate Maven, Apache, Java, and Ubuntu. They're actually going to share those layers, and that means that your system actually doesn't have to run all 3 of these. They just share the read-only stack, and then you have the custom image on top. So this is where a lot of the efficiency gains come from, which is just the ability to share these layers and not having to repeat parts of the application that are duplicated over different containers. This often leads to the next question, which is, well, if that's the case, how many containers can I run on a host? Again, this is a very difficult question to answer because it really depends. First, we know that some folks associate containers with microservices architectures. They do work very well together when companies are leveraging these new architectures and leveraging microservices. So when microservices tend to be very small in scale because they're doing very bite-sized functions, but when you're taking an application, like let's say you have a custom order entry system for your business, that can take a lot more microservices or a lot more separate containers than a single monolithic app. So there's a higher quantity of containers to support it, but then each container would be very small. On the flip side, if you've been following Docker in the last year, you'll know that what we have seen is the benefits of containerizing traditional monolithic apps as well. And so this is taking your basic existing .NET or Java application, packaging it inside a container for additional layers of portability and ability to address issues and maintenance and speed up delivery and deployment. Now, if you do this, if you actually containerize a traditional app, they will tend to be larger. And so when you talk about the resources on your host and the differences in memory and compute that you have, and also the differences in the architecture of the application, it's really difficult to give an answer on how many containers you can run on a host. It's sort of, it depends. Now, there are things that people can do to optimize on how much space a container takes inside your infrastructure. One of the key things is leveraging a lightweight host OS, something like Alpine Linux or Docker's Linux Kit project, which is part of the Moby project. So if you go back, and I'm just going to flash back to this picture, what you realize is in the end, the key aspects that you need in your host operating system for Docker is the kernel operations, and then the next few layers depend on what application stack you're building on. So the key here is to use a minimalist OS that only gives you the pieces you need. By only leveraging the pieces you need, you can cut out some of the fat in the operating system and save a lot of space both in your image size and your container runtime. And so this is a general recommendation for optimizing the size of your containers. The other part of optimization is actually not really in the IT operator's wheelhouse. It's really something that the developers should consider. So if your developers aren't aware of these and you're seeing large containers that you think can be less or can be more ideally sized, it is worthwhile to talk to your developer teams to see if they're leveraging some of the ways to optimize their images. One of the newer features that was released in our 17.06 Community Edition release is a feature called multi-stage build. This is a way to let developers basically cut the fat in terms of when they're ready to move a image from development to production. So the idea being, as a developer is working on code, they may be adding packages to an image that are no longer needed when it's ready to go. Multi-stage builds gives you an ability to kind of cut those unneeded pieces out of your image. There are other tools out there and a lot of documentation and blogs and things like that. Docker Ignore is another way to optimize the size of the image. It allows you to kind of exclude certain processes that are unneeded. Okay, so next question. From an infrastructure standpoint, what do I need from Docker? Is Docker a piece of hardware running in my data center? So when we talk about Docker, again, there's Community Edition and Enterprise Edition. And within Enterprise Edition, there is a concept of Enterprise Edition Basic versus Standard and Advanced. Now, when we talk about Enterprise Edition, Standard, and Advanced, what you get on top of the basic engine is two core components, Docker Trusted Registry and Docker Universal Control Plane. So the two pieces that we discuss here are a management stack and a private registry for those enterprise production use cases. And when you are interested in managing the life cycle of Docker containers and having monitoring, access controls, security policies, etc., what you are going to be doing is actually installing this management stack in either your own data center or something like a virtual private cloud in AWS or the equivalent in Azure. So it is installed software, and how it works is to get that management stack, you would have at least 3 manager nodes. These are so that you have some high availability in your management stack. These manager nodes are in itself basically like a wrap consensus swarm cluster. What they do is they duplicate all of the your cluster settings over 3 different nodes so that if any single node fails, there is still quorum and consensus on what the setting of the cluster is. On top of that, let me go back. These managers then manage the actual hosts, the worker nodes. These are the hosts that are running containers themselves. And so this is where you get that management stack for managing the containers. Now, if you're interested in the private registry, then you also need to set up at least three, again, for high availability reasons, what we call replica workers. And so these DTR replica workers is what manages your image registry. So again, this ends up being the footprint that you would install either in your own data center or in a virtual private cloud in the cloud, or in the public cloud. Now, when I talk about nodes, these nodes can be virtual machines or they can be physical bare metal nodes. So if you think about the reasons why some customers may want to run on bare metal, we talked about performance or resource efficiencies, then each of these nodes that we talk about are a physical server. But otherwise, each of these nodes can also be, again, virtual machine. But yes, it's an installed product. It's something you would manage. That's where we say this is a tool for IT, and IT typically would manage this environment for the developer teams to manage their images, and then IT operations teams to deploy these containers. Because it is an installed product, and it's sometimes difficult for people to understand what exactly you can see. So what we have is recently we launched a new Docker trial environment, which is a hosted demo environment for you to understand and learn what Docker EE is. So I will send the link, or I'll show you the link at the end of this presentation, but just so everybody knows, if you're interested in understanding more about Docker EE, go to Docker Trial, that's one word, dockertrial.com, and when you register, you'll have access to this hosted demo environment, which is a fully virtualized environment for you to explore. So if people are familiar with hands-on labs in the VMware world, it's similar to that, which is it's a CAN deployment. You get access to it for 4 hours. At the end of the 4 hours, the environment dies, and you can refresh it, and you get a new build. Okay, next question. Are containers only good for stateless applications? So if you are familiar with how container runtime is built on, is based on an image, then it seems to be that if the container dies, you just rebuild the image, which means that that is good for stateless applications. But really, containers work with both stateless and stateful applications. How we support stateful applications is through things like our Docker Volume Driver or Docker Volume plugins. Docker Volume Driver is the built-in volume driver that is included in your Docker Community Edition as well as Enterprise Edition. However, our company always supports what we call the batteries included but swappable or replaceable. So the idea being that, yes, we have our own Docker Volume Driver, but you're also welcome to use a volume plugin from a third-party source. Now, these Docker Volume plugins are in our Docker store, and we have several certified plugins that are from the major storage vendors out there, EMC, NetApp, et cetera, et cetera. So with the Docker Volume plugins, we can support persistent volumes. And so when a container dies for any reason, the data is still remaining inside those persistent volumes so that when the container is reloaded, it can attach itself to that volume and everything continues. So stateful applications are definitely possible and are definitely being used in production. Sometimes this leads to questions, well, what exactly happens when a host goes down or a Docker container goes down? Is there the concept of like high availability for Docker containers? So there's a couple things that we can do that is a little different from the virtual machine world where high availability is very well understood. So one of the things is when you talk about running those different worker nodes in a cluster, the swarm mode orchestration tools, which are built into Docker, allow the definition of what an application should look like. And by defining an application that can be several containers, there is a self-healing aspect of this which recovers your workloads if a host were to go down. So the best way to explain it is think of an application where you will have 3 replicas of the same container. What happens is the orchestrator, the swarm mode orchestrator, will deploy 3 containers across the cluster based on the rules and constraints that you might have set. Now, when, let's say, one of the hosts goes down or is disconnected from the swarm, the orchestrator will say, we'll see that there's only 2 copies of the replica, and it will reinstantiate a third in an available host because it wants to maintain that declarative state of 3 replicas. How it does this is it's all based on the image, remember. So container runtimes are based on your image. In the image file, which is stored in something like Docker Trusted Registry, is sort of the blueprint for the container runtime. So what the swarm mode orchestrator does is it says, I need to restart a new container on one of my available hosts, and I will pull that container from the image. And now if you combine this aspect with what we just talked about, which is storage volumes, then you can also see that the key thing is not so much backing up your container runtime, because really that's all based on the image. What you do need to do is back up your images and back up the actual data volumes. So backing up your images, that's where we go back to how you set up Docker Trusted Registry. Is we recommend at least 3 nodes, and that's, again, because you want to make sure that that environment is able to survive different failures. And so you'll have copies of that image in all 3 different replica nodes. And it doesn't have to be 3, by the way. It can be any number of, depending on what your fault tolerance is, but we do recommend 3, 5, or 7. But the idea being that when you want to make sure your images are highly available. And then and the second part being, you want to make sure that the storage volumes are available too. So then you can rely on traditional storage tactics for backup and disaster recovery and things like that. So you can leverage the existing storage capabilities for keeping your work online, or your containers online. So we've talked about storage. Let's move to networking. How do containers talk to each other? How does networking work with containers? So this is a topic that we could talk about for an hour on its own, and what we're going to do is schedule another upcoming webinar on how networking works. Today I'm just going to kind of give you the brief overview. So there's 3 types of networking that are available for Docker containers. There's bridge overlay, which leverages VXLAN, and MACVLAN. Each one has its own reasons and pros and cons, and it again kind of depends on what you want to do with your applications and your environment. So before we get started, though, let's just make sure we're all on the same page. The container networking model was designed with the basic Linux container technology, and so what Docker did was take that basic function, and we created the lib network, which is a sort of the Docker's version of the container networking model. How it works is, inside your container you'll have a sandbox with an endpoint, and that endpoint will be connected to the external networks. How containers talk to each other then is that they have to share some networks, and those are defined in 3 different models that we talked about. It can be defined as bridge networks, overlay networks, or MACVLAN networks. So let's talk quickly about bridge networking. This is probably the simplest. It's great for working on your own laptop. If you've got, your Mac or Windows-based laptop, you can support single host networking between containers. So what it basically does is creates a bridge, which is a virtual switch, and you can connect different containers to different bridges. The key here, though, is that it is within a single host. So you would have a bridge network within one host and a bridge network on a second host, but those 2 cannot talk to each other. So they are completely host-oriented and is limited to only containers running on that single host. So again, this is great for test and dev if you're just starting to play on your laptop and want to see how this works. That is very much the first kind of level of networking. When it comes to bridge networking, one of the things that you'll have to do, though, is understand port mapping, because there is the internal network of the container versus the physical network that is externally viewable. And so if you are, there's a great example if you just want to run a application on your local host in the Mac, you would do a port map so that you can map the external port with the container port. The second type, though, is now if you do want to have your different Docker hosts be able to communicate with each other, then you'll want to leverage something called an overlay network or MACVLAN. Now, the overlay network leverages VXLAN technology. So it's very similar to a virtualized network in the VMware world, which is, leveraging subnets that are layered on top of the physical network. And so this is the exact same concept. So you might have two different hosts, each one with a physical address, and then you would create this overlay subnet that is a logical network on top of so it's like layer 3 on top of layer 2. And then your different containers on these different hosts can adopt the IP addresses within that subnet. And again, this leverages the VXLAN tunnel and is very similar to how you would do virtual networking with virtual machines. And then the last networking model is MACVLAN. So this is another way of getting different containers on different hosts to be able to communicate with each other. But it is better for mixing virtual machines and physical machines, and a way to do this internally in your own data center. So the one gotcha on MACVLAN that a lot of people need to know, though, and I'm not going to go deep into this, but it is that it does require promiscuous mode, which is not available in a lot of public clouds. So again, MACVLAN is very useful inside the data center, but you'll probably leverage the overlay network more often in a public cloud environment. All right, so those are the top questions we get from IT admins, oftentimes, again, from trade shows and events we're doing. What I'll do now is jump over to Q&A. So let me stop sharing and start to see what questions have been asked. And there are no questions. So either I mastered everything, or please just let me know if there's anything you guys want to know. I'll wait a few minutes, but enter them into the Q&A window and let me know if there is anything I didn't address. All right, we got our first question. Can you please share the slides? So the this presentation will be recorded and is recorded, sorry, and will be made available to you guys after this session. It'll be about 2 days from now. You'll receive an email with the recording. And yeah, if there's any other problems there, you can always reach out to webinars@docker.com. Another question, do we have support for Docker for Windows using VMware Workstation, Windows 10? Yes, so there is a Docker for Windows 10, and what you can do is, it's actually what happens in the Mac. Docker for Mac, what happens is we actually leverage a Linux virtual machine, and when I run Docker for Mac, and I can kind of show you guys that real fast. Let me see, I had a terminal open. So this is Docker for Mac, and I can show you Docker version. It will tell you I'm running 17.06 Community Edition. What this is actually doing is it's running a Linux virtual machine on my Mac OS with Docker installed. So in the same vein, you can run a virtual machine like Workstation, load that with Windows 10, and then run Docker for Windows on top of that. So Docker has a great partnership with Microsoft. We have been working together to bring all the benefits of Linux containers to the Windows environment. It works on Windows 10 as well as Windows Server 2016. One of the key things there is that we really look at we've replicated and worked with the Windows engineering team to ensure that the same commands and the same CLI and the same, compose files and everything work the same way they do for Linux containers as well as Windows containers. It's a great question. Let me go back. Okay, there's a request to see one of the slides again. So let me go to the presentation and jump back to it. So this is about sharing layers. This is a really big concept in terms of difference between a virtual machine and a container, and it's also, again, one of the reasons that containers can be more efficient. So if I haven't explained it very well, the idea here is that when you build an image, and I'm going to go back here. Let's say that your application uses Apache, Emacs, and Debian. You build this image, and these are read-only portions of the image. They're just pieces of code that are fixed in place that create the stack for your actual app. Now, the actual app is the writable part. That's the part that gets actually changed and gets updated and gets leveraged for the specific application. So if we go back to this slide, these are different. So my app 1 through 4 are all very different, but they leverage a lot of common traits of the stack. And so these pieces, the Java, Apache, and Maven, or Java, Apache, and Ant, don't have to get recreated in memory each time. It leverages the same read-only blocks in memory. So that's, again, so this particular app 2 will just deploy and read the writable piece of that application and leverage the read-only blocks of these stacks. So hopefully that was good clarification. All right. Let's see. Any other questions before I go to the last slide? How can I access symbolic links on the host inside the container? So that's a very good question that I will have to address offline, and we will send you a response. So I will save this Q&A, and I'll make sure to send you a response. Otherwise, let me go just give you some things for the next steps. So if you're, again, getting started with Docker now, what we will recommend is you can try this new hosted demo environment, dockertrial.com. If you want to follow some self-paced exercises on your own laptop or you're in the browser window, you can also leverage our Play with Docker environment, which the link is here. We have several other videos and demos on Docker EE that you can leverage, look for on YouTube. There is a link here, but it'll be in the recording. And again, if you would like to learn more, join us on our multi-part learning series. Go to docker.com/itpro, and we will regularly update that page. You can also sign up for our newsletter there, where we'll make sure that you are up to speed on the next steps of this learning. There's also upcoming webinars. Again, next Tuesday, or this coming Tuesday, I should say, we are doing the business value of Docker, and we recommend you join that and learn more about how we are able to save organizations money. And then finally, we have resources on our website for you to download, things like white papers, technical briefs, solution briefs, etc. So with that, I thank everybody for joining us today. And again, I have 2 last questions that came in late, but I will send an email to respond to those right after this webinar. All right, so thank you, everybody, and hope everyone has a great weekend. Talk to you soon.